goes to the cloud. I put MDCS there to try and compare how that fits into a traditional HPC environment. And anyone other than the MDCS person, can you guess how that fits in?
What's the question?
The difference between this and let's call it your management, because that's all this really is. It's a management layer compared to that. And more importantly, can they coexist?
It doesn't have the data cluster, as far as I know.
That's more of the hardware setup.
Yeah. You can, so in this group of files, local machines, depends how you set it up.
Good engineering answer, it depends.
I think the Matlab code you write has to know how to retrieve the data. So the standard approach is to just fix it. You can either put it all on data, you can distribute locally, but each worker has to know how to retrieve its data. I don't know how that fits in. Maybe if you have to use a more complex file system, I don't know how it works.
So
there are also different ways you can apply the parallelization. So you've got the par for loop, which is a traditional for loop that you can run, that will run on the different nodes. And then you get the single program multiple data, where which will be operate similarly to the distributed file system. You distribute the data and have one algorithm working with all the different aspects. So you got some flexibility.
So how it really fits in is actually in all of those scenarios. It's just that it doesn't play nicely if you've got other applications using other things. Matlab and this works nicely in its environment, but you do need them to talk to each other and work together. So in Linux, they actually do work nicely together. In a Windows environment, it's much more interactive, setting up those scheduling environments and resources, and it doesn't play nicely. But in a Linux environment, they actually do coexist. So the PBSs and all of these things actually do work with the Matlab environment. So you can, and many universities actually internationally. I spoke to the PBS guys specifically. They've given me their scripts and how they do it. So we can actually do that and put Matlab on a traditional cluster environment. Any other general questions? I think that was quite a lot of information.
Well, maybe you can explain like how what CrunchYard's thing is versus Microsoft Server.
Okay. Maybe a bit of history. So I worked at Pointing, which was an antenna company, and they had their software package called SuperNIC. And one day we sat down and said, how do we do this differently? How do we commercialize it differently? And Andre Farid said, well, let's put it on the internet on a pay-per-use basis. And that's where it really started. So try to figure out, took a year to figure out how to do this, and constructed a cluster with a web front end so people can just submit jobs and it just goes through and you can get things processed. We very quickly realized antennas are some of the smallest simulations you can actually get. Exploration geophysics are some of the biggest. So seismic, this was about 3 years ago. The big problems they were talking about, the input file, just the input file was a petabyte, and they needed 100,000 cores to solve that. So that's big. We weren't anywhere near that, with our small little cluster. Over time, so we offered that and we started putting more applications on. Over time we realized, and our clients actually said to us, the workflow doesn't actually totally fit that. And that workflow that I did previously of your workstation, your local compute, and then cloud. So we've done the cloud. And now we're busy with things called crunch stations. So you can actually get 112 cores on a single box. With its own scheduler, so it's a mini cluster, so it's on your desktop. So you can work together locally, and then this can then push or talk to a queuing system of the cloud environment. So that's actually what CrunchYard's doing now. Where we're partnering with Microsoft is that we're still doing this, but we do that setup in the cloud and set up those architectures for people in the Azure cloud. and we partner with Microsoft to do that. Does that answer the question? Very general.
Yes. I think people will be very intrigued to hear how you set up MDCS on the Crunch station.
So that's what we're busy with at the moment is the prototyping. Just draw the workflow again. Workstation. Crunch station. We're going to call this Azure / CrunchYard. So what we're busy with Kirsten and Daniel Talita is guys have got their code and they're writing it. They might have licenses, a certain number of licenses that they can then push there and they can test things locally. And you have your MDCS and GPUs and a whole bunch of things to do those local computes. And obviously you get testing and you can do that until you get a bigger environment and then push the Matlab stuff there. And that's why I mentioned PBS talks nicely to Matlab or to MDCS, because it was part of my big concerns. How do you get the environments to talk to each other? So I haven't actually played with it, but I've got the code to do that. So that's pretty much what we're busy with, is putting a proof of concept together for this environment, so that people can go to extremes with their data when they need to.
So how would that work? Is that like you pretend that Azure is like an MDCS, or like how does it work with Matlab?
So instead of calling it MDCS, just call it a resource manager or queuing system, because that's all that MDCS really is. Resource. When your resource manager says there's no more resources, it talks to this resource manager. And this guy says, I've got stuff. And then it says, okay, here we go, please do this. So it's the resource managers that will be talking to each other, and you can obviously enable or disable that talking.
So does PBS replace MDCS when you get onto the cloud to go and scale it up there? Okay. Interesting. I wonder what that looks.
Not necessarily.
Okay.
It's going to depend on what the proof of concept shows. But it'll be nice, seeing as PBS does talk nicely with Matlab in a Linux environment. That would be a nice thing to do, because it's a standard.
Yes.
And then you can actually do other things, like other software programs, like Alaris. They've got their Matlab stuff, and a little code to interact with FICO.
Okay. Yes.
And FICO works very nicely because it's actually owned by the same company now. PBS is owned by Alte. So they talk nicely together. So to get at that homogeneous environment is perfect.
Okay.
Yes.
There's a company called Tequila, and then Tequila.
The name half rings a bell.
Yeah.
Saturday nights.
Tiffany Dalbora.
No, I came across it somewhere else. It's overseas somewhere. But effectively, what they do, they offer a service where, and what I was surprised by is Matlab, one of the things that they said they can use, where you'll have, they'll say, you've got an application, say it's a Matlab application, and they can scale that to the cloud straight away. So apparently they've got something, I don't know if it's software or if they have hundreds of people that will be coded overnight. But apparently overnight you'll have something that can run with massively parallel environments. As far as I understand, it does not use MDCS at all.
It's MDCS is just really a resource manager.
And a source of revenue.
And a source of revenue, yes. The way that they must probably do it is look at path wars to instantly get massive scaling, because that's easy. But certain applications cannot be parallelized. They literally cannot, and bioinformatics is one of them. So they rather have a single fat node with a terabyte of RAM to fit all the data in than to drive. This, by the way, is called a distributed memory paradigm, because the memory is distributed, so your RAM is distributed. You can take a problem and distribute it. Shared memory is where they obviously share, where you've got a big thing and they all share the same RAM. So I'd be very surprised if it can take any problem, because
I'm sure that was a market scheme. I was
sure.
interested in, and maybe it's the workflow there between the crunch station and then moving on to something that's perhaps Azure.
Yes.
Where MDCS fits into that. Because even your Power, for example, I'm incredibly clued up on this, but in theory you still require MDCS.
Yeah.
On
So
the licensing side at least to run that.
you'd still keep it there, but the resource manager would be PBS. You wouldn't rely on necessarily MDCS to do it. You might, because we can actually partition that off as a separate cluster, but then how do other applications that you might want to interact with work?
Yeah. And also the licensing issue, obviously people buy a certain number of MDCS loads, so what does that mean? Are they eligible to go and pay a bit more to
So
scale it up?
the licensing model is a whole talk on its own,
Yeah.
because it's a minefield. It's actually the biggest problem people face. It's not the technical stuff. The biggest problem is licensing. How do you talk to licensing? What are the various schemes? Because some of them go from you're only allowed to use a license within a 5 kilometer radius of your work. In a cloud world, it's very weird. To you can use unlimited nodes for a certain license for a certain. So you pay for a month, and this is the Star CCM guys. They say unlimited nodes for your power license for a month. You buy that and make sure you use that. So the licensing is quite a minefield. So the better approach is to have a licensing manager sitting in Azure somewhere, because then locally you can connect to your license manager, and when you're in Azure you can connect to the license manager. You don't have to worry too much about trying to connect from there through a firewall here somewhere. So this setup is actually better. Have your license manager sitting in the cloud.
Right.
Yes.
In terms of data, if you worked on your workstation, now you've upgraded to the crunch station, how would you actually, would Azure then access the data that you have on the local machine? You have to transfer it, upload it into the web? How would you actually manage that?
The better solution is actually to transfer it, and I know it's an issue when you get large data sets, but you do one transfer up, you put it there.
Yeah, so it won't be a good idea for petabyte.
No, you can ship hard drives,
Okay.
and some simulation companies actually say they're in the business of shipping hard drives. The data analysis is just by the way. Shipping hard drives is still a viable option, but with fiber coming, and I might not have mentioned this, but Azure is building a facility in Johannesburg. So you're going to get much faster access to stuff. So
Okay, so people can go drop off their database.
petabyte, I'd still recommend you go, but petabyte, I don't know if you know how many hard drives that is, how heavy that actually is. You have to have your own facility pretty much dedicated for something like that. Yes.
Who's currently using CrunchStation?
Who's currently, so this, the bigger one we've got is 112 cores. That's ESCOM's Specialization Center for Combustion Engineering. It's a research center at BITS. And when they model their boilers, so they've got to model how they inject coal with air and swirl it. And they've got to swirl it in various ways so that the flame is right to get the right burn rate and energy out of that. That's complex, extremely complex, because that's fluid flow, particle flow, thermal. It's all of these multi-physics things. So they are one of the biggest users of this. And obviously Alaris have got a smaller version of this locally as well. So it's quite a new thing. But those are most of the, yeah. We've got quite a lot of interest. You can do actually more with this. Another client had a weird request. they've got an application that uses Microsoft's SQL database, but the performance was not quite good. To buy more licenses, to go multi-core is prohibitively expensive. So they came to us and said, is there another solution? So we came up with a hardware solution instead, which uses many SSDs in an arrayed and parallel file configuration. So you get near RAM speed from your hard drive, which improves your performance without going multi-core. So that was a sort of a weird combination of things, but it worked quite well. So parallelism and redundancy and performance. Yeah. Any other questions? Okay. Well, thank you very much for listening, and thanks for the interaction.
Thank you.